Okay. You can reply in chat box if you guys have. Okay, looks like few of you are raising hands. Okay. First thing, you will need a Ubuntu and ROS software installed. I'll be share. I think maybe after the session or something, I can share you guys the installation link. But for now, since time is short and I have a lot to cover, I'll just go ahead and I will give you a demo session more than a hands-on session. I'll just execute it in my system and show it to you guys. I'm not sure how helpful it will be, but I think you'll at least get an idea of how things work. So, uh, ROS Wiki is the official tutorials page for ROS. So we will see what and all is available, a few terminology that is generally used in ROS here. So I'll not waste time, I'll directly jump in. So first, okay, this is all about establishing your environment or creating a setup. So I'll skip this part. You can do this when installing. I can share the resources to you guys later. Okay. First thing that we can cover up, or first terminology that we'll be using much, is a ROS workspace. So ROS workspace is nothing but a directory or a folder where you write your code or store your code. Why is it called a workspace? Because for every different projects or for different kind of thing, as I said, ROS is a structured software. So whatever you write, you keep it in a definite folders or a structure. So all your code that you'll be writing, you will be keeping it in a workspace, and you are gonna build or compile your code there. So it will, you will have your compiled files, developed files, and all that storing in one single place. So we will see how to make a ROS workspace first. Whatever code or software that you're writing will be in a single place called as your ROS workspace. Anything out of your ROS workspace, you cannot run it or access it with your ROS. So as you can see in this documentation page, you have a lot of theory given and commands and everything. You can go through all of these, it will be helpful. But what I will be doing right now is like a, I'll be telling you guys all the stuff that's already here, or if there's any extra information, you can go through the documentation page when you have time. But for now, for a fast reference, I'll be teaching you guys these things. So for those of you who are not even you know familiar with Linux, I can explain the basic codes for you. Like the first command here is called make directory. This will create a folder in your whatever path you give. Like here, I am telling in my root directory, I want a folder called as Catkin workspace and another folder called as source inside it. So that is what this command will do. So now if I check my folder here, I have a folder called as Catkin workspace here. So inside that I have a source written. So whatever code you're writing, you will be writing all of that inside this source here. And after that, you are after that you are moving back to your Catkin workspace. That means you are entering to your Catkin workspace. And again, if you're not familiar, whatever commands you want to run from, if you want to run it from a certain directory, you can navigate to the folder you need using the command cd, that is change directory. So you can move in and move out of directories using this command. So after that, whatever code you want to compile or run, this is the command that you will be using, catkin make. It might be hard for you to grasp onto things, but you can always refer to your documentation pages whenever you're running, at least when you're starting off. You the more practice you get, the you might remember all of this quicker. But yeah, make directory is for creating a folder, and whatever name you want to give, you can mention after that. That and CD stands for change directory. That is, if you want to navigate to any files or within the files. And catkin make is a command you use for compiling your code. So after you compile the code, if you look at your folder structure now, there is a new file called as cmakelist.txt inside your source folder, and two new folders that appear in your catkin workspace, or the in your workspace, that is the build and develop files. So these are like the binary versions or the machine readable versions that your uh, or the compiled version of the code that you have written. As of now, there's no code that I have written in my source, but still I have a few files and all these folder structures developed. So these are like the basic or the minimum requirements for my ROS to identify my files, or to identify that there's a workspace here. So that, and additionally, every time you compile your code, you will have to run this command called as source devel slash setup.bash. So what this command does is, so in your compiled code, inside the develop folder, there is a setup dot sorry, there's a setup.bash file. So this gives you the basic information of where what is stored. So you want to load this information inside your terminal, because whatever command you run from your terminal should be should be able to tell what executables it have and what binary files it has. It should be able to recognize some. If you are telling that I want to run this file, for the terminal to make sure that that file exists, or there's an executable with that name, it needs that information. So the all that kind of an executable information or the binary information to recognize what files are there, what files are not there, that information will be stored in this setup.bash. So you're sourcing that in file into your terminal. So all you have to remember is, whenever you want to write a code, this is a basic. First, you create a workspace with a source folder, and then you compile it using catkin make, and then whatever compiled version of code you or the compiled documents you have or the files you have, you source that into your terminal. So this is the basic step every time you use for whenever you start off with a ROS program, or you start writing a code. I hope I'm just not going very fast and you guys can understand stuff. Okay, anyone, any of you have any doubts till whatever has been covered till here? What is a workspace? Why do you source, or how do you compile? Just be interactive and tell me if you want me to go more slow, you need more explanation to things. Uh, I'm not in the meet. If you guys are using chat box, I want one of you to open up and tell me if things are fine till here.
I joined the meeting like 10 minutes late. Can you just please tell me why are we using Ubuntu and what is ROS?
Okay, sure. Okay. So first thing, ROS stands for Robot Operating System. So what this ROS? What is ROS? Okay. So ROS stands for Robot Operating System. This is a software framework that you use when you're programming or setting up your software, or you're programming your robots, because ROS comes with basic functionality or already available software which helps you communicate with the hardware in your robot, or exchange information between your robot and the software. As you know, a robot has hardware and software. So you need a framework that can communicate between your software and hardware, where you can program You all know that you can program using C++, C, Python, or whatever. But what connects between your hardware and source on your software? You need some framework, right? So ROS is such a framework where you can exchange information between your hardware and software. Usually, now there are two versions of ROS, ROS 1 and ROS 2. ROS 1 is the first version that ever came out, and ROS is more free to use or flexible to use when it has more compatibility in your Ubuntu or Linux systems. So that is why we use it in Ubuntu. To answer your question, and ROS 1 is a little bit easier to grasp if you are learning it for the first time, and ROS 2 if you already are aware of ROS 1, then it'll be helpful to learn ROS 2 because it has a little bit more added complexity. But for now, for you guys, ROS 1 is good enough. So we will be learning ROS 1 here. So I was just telling, um, how where will you write your code, or what is the basic step when you have to start off with the code. If you're writing a Python program or a C++ program, you just open your editor, you write your piece of code, and then you run a command in your terminal to compile it. In a similar way, when you are programming something, how do you store it, where do you store it, are you using any kind of IDEs or whatever? So when it comes to ROS, first thing is you create a folder called as a workspace, and what inside that you create a source folder, and whatever code you're writing, you write your code inside this. Whatever files you're making, you write your files in this inside this source folder in your workspace. So, and when you are compiling it, you have to compile your code being in the workspace directory, and inside your workspace directory you compile the code using the command catkin make. So this command is used to compile your code, and after you compile your code, you do something called as sourcing your file. The You have a single statement, or it is called as, this is the command.
Sorry to interrupt, but can you please increase the font size?
Okay, is this better?
Yeah.
Okay. So now after you make catkin inside your root folder, you make something, a directory called as catkin workspace, and inside that you have a source folder. And after this part, if you run a command called as catkin make, this command here is used to create your folder, and you navigate to your workspace, and then you run catkin make. This catkin make command is used to compile your code. After you compile the code, you will see that this build and develop folders are generated. Inside this, there'll be a binary version or executable versions of your software that you have written in your source folder, or the minimum required files for ROS to identify your workspace, your packages, and your software. So inside this develop file, there is another file called as setup.bash, which stores the required information for your system to identify the binary files it has or the packages it has. So you need to source this file in your software. You do that using this command, source develop setup.bash. This is nothing but the location of your setup file. So you will just run it with the source command here. All of these commands are available in the documentation page here. You can always refer this documentation page whenever you're working in with some code. This demo here is just for you to know what it is, how it is, but when you're referring, you don't have to remember all this complex stuff or the commands because they're new to you. You won't even remember it. So you can just I'm just telling you where you can refer for what. I'm just giving you a walk on for whatever can be done or what has to be done. All these references I will be sharing to you after the class or the session. So till now what we have covered is we made a folder called as a workspace, and inside that we have a source folder where we'll be writing our code. And then we will, for compiling the code, we use catkin make, and every time we compile the code we have to source the setup file. So that is done using this source file. So clear here? I hope you guys are clear.
We can install ROS in Windows as well, right? Like I found a documentation from their official website where they have given a bunch of
ROS 1 you cannot install in Windows because it is not very compatible. But if you're using ROS 2, you can use it in Windows. But ROS 2 has a little bit of syntax differences and a little differences in the framework here and there. But it's almost similar to ROS, whatever terminology that you're using. But it's a little different compared to ROS. But I suggest, because you're using it like the first time or anything, I suggest you go with Ubuntu instead of Windows and install ROS Noetic better than ROS 2, because ROS 2 is a little bit more complex compared to ROS.
Does that apply for Mac also?
Yes. Ubuntu is better. Whatever, Ubuntu was made for developers. So this is the most flexible system out there. So this is the basic setup that you have to do. Moving on, now we will see a ROS file system. This again we have covered a little bit. Okay. File system is nothing but how the packages or your software is stored in your folder structure. So what we have is called as a workspace. Inside workspace, you'll have a source folder, and inside your source folder, you will have packages. Packages again are like a folder itself in which you'll have your actual files. So packages are the software organization unit of ROS code. Nothing but again is a folder containing your software files. These packages, it can contain libraries, executable scripts, and other stuff. And then there are certain tools called as file system tools. These are handy when you want to debug your code or find certain things. Like there is a command, this comes with ROS. So there's a command called as ROSpack find, and you give a package name. So I will show you with an already existing file that I have with me. Suppose this is a workspace that I already had. Inside this, there's a source folder. And inside this, I have certain more folders. These are called as packages. So inside these packages, I will have my scripts, or this is a normal Python script that I have inside this, or any other files that are required for my, or any dependencies that I have, or other files. These are again other files that I have script codes here. So all of these together is called as a package. So if you want to find out the package name or where your package is located, you just know the package name and you don't know where it is. You want the exact address. In that case, if you want to find your certain package, you can use this command called as ROSpack find and your package name. You can simply run this command in your terminal and you'll be able to find. For example, here there's something called as ROS CPP. Even I have this file in my system. So if I just, before all that, there is a command called as ROS core. You need to run this for your ROS master to begin. ROS master is nothing but more like a, if you're aware of server client systems, server is something that has the information or that communicates with your client files, right? So ROS master here is like, it has all the information of what and all files are in your system or the commands to identify any commands and all that. So this ROS core is like your master. So you can run this in one terminal, and in your other terminals you can run whatever code commands that you have. So here ROS pack find ROS CPP. ROS CPP is a package that I have in my system, but I don't know where it is. So if I run this, I will be able to get the location of this package. So certain more file system tools that we have is ROS CD. So suppose I want to navigate inside my package, or then I can use this ROS CD. So if I run this command, my terminal location is gonna change. My terminal before it was in Catkin workspace. Now it has changed to the location of ROS CPP, or my whatever package name that I am using here. And this is a basic Unix command or a Linux command, pwd. This will print the name of the working directory. That is nothing but this opt-ROS noetic share ROS CPP, or before this it was Catkin workspace. So wherever you are, which directory you're working in, it will just return the file name. I'm not gonna run everything because we are short on time. You can go through these pages again.
I have a doubt actually.
Yeah, please.
Is this, I mean, for ROS, we said that we're going to be coding software, correct? I mean, we
Yeah.
use that to communicate with the hardware. So is Ubuntu, is the terminal in Ubuntu only the environment for this?
Sorry.
Is the coding environment the terminal itself?
No, if you have a Visual Studio Code that you want to use, or any editor, you can use it. That is where you will be writing your files or scripts, Python or C++, and then you will be storing it in certain folder structure here. And for executing those files or compiling those codes, that is where you will be using your terminal. Like how you run a Python code, you write the script in some editor, and then you store it in some place, and for compiling that and running the code, you use your terminal. Same here. When you're saving your script, you have certain file structure that you have to follow. That is all the difference is. Otherwise you will be writing your script in any kind of editor, and then you will be compiling and running it with your terminal. The commands that you use and the way you save the file is different here. That is the only difference.
And is TurtleSim and RWiz supported in ROS 1?
Yeah, it is supported. Okay, and we have ls tool in normal Linux that will be printing all the existing files inside the directory. So similarly, we have ROS ls, where you followed by your package name, it will return all the files or directories present inside the package. So now going back. Okay. Okay. Now I'm in my Catkin workspace directly. Now if I give ls, it will print what and all is present inside my directory, right? This is a normal Unix command or a Linux command. So similarly, if I want to see what inside a certain package without navigating and stuff, I can directly run this ROS ls and then followed by my package name. So inside this, I have cmake file, which is a default file that comes with your package, and then a launch file. This is a folder that the user has written. Package.xml is again a default file, and then another folder called as srv. So it is the same as here. I have the same package here in my system, and you can see that what it returns. And another useful tool that we use is tab completion. So suppose now I want to move to my ROS CPP package. Now I have typed out the command, but after this, if I just half type and then click on my tab key doubles, it will give me an options of what and all is available. This is in case you don't remember the full name or you are lazy to type or something like that. So I just need to, if you have a doubt in the spelling and stuff like that. Again, after if that is the only option available again, now if you see, I have typed till here, and then again I did a double press of my tab, and the name got auto completed without me typing it. So whenever you have a doubt with your spellings or something like that, you can do tab completion. So it will give you an options of what and all is available, or it will help you fill it. If that is the only option available, it will autofill. So most probably you'll be using this tab completion very frequently. Okay. These were the basic file system or navigation tools that we use. There are other stuff also that we will be checking now. So are you guys comfortable till here, or you have any doubts? If you guys want me to go slow or repeat something, please tell me. Okay, I take the silence as nothing more to tell. Okay, the next topic that we'll be looking at is what is a ROS package and how we create a ROS package. So as I told, ROS package, it has a few it is a definite structure, or it is a structure where you store your script files or any other dependencies or any other files you want to store, your source files or script files that you'll be storing, that will be inside a package. So to create a package, there is a command called as catkin create, followed by your package name, and then any dependencies that you want to give. So this will be the command that you'll be using for creating a ROS package. So for example, here there is something, these people are creating beginner tutorials, and then some dependencies. These dependencies, by dependencies I mean any existing libraries or source codes that are already available in ROS. For example, here in this example, they made use of something called as standard messages. So this standard messages is a library file where it has the definitions of certain message types. And then ROSPy is used to identify ROS commands or ROS features. And ROS CPP, if you're using the C++ version of ROS, or you're gonna write your code in C++. If you're writing Python files, ROSPy is good enough to use. So something like this, if you have any dependencies that you want to add, then you can list out your dependencies here after your package name. But the main command that you use is catkin create package. Okay. And when you create a package, this will be your package structure. Inside your package, there'll be two default files that will be coming along. One is cmakelist.txt and package.xml. I would say you don't have to worry or look into these files as of now. But this will be your final structure. Inside your workspace folder, you will have a source folder. And then inside your source folder, you will have your package. And inside this package, you will have a few default files and whatever extra files that you will be writing, your script files. So now, since I am already in my catkin workspace, I will create a package here. So I'll be changing my directory inside the source folder, and here I will create my package. The command for that is catkin create package, and I can give my package name. And if I'm gonna make use of mm, any dependencies, I can mention them, and this will give a successfully created files. It will give me a message that it has my package is successfully created. Now looking inside your folder, inside your Catkin workspace, there's a source folder inside which your package is created. Inside your package, you again have two default packages and again a source folder where you can write your scripts, or you can just create another folder here and any number of folders here, and then you can write your scripts. Or you can write them directly also without any folders. That is left for the user. And again, after creating your package, you need to compile your package again. So for that, you need to go back to your Catkin workspace. You cannot run your Catkin make from inside your source folder. This is a common mistake which people do. You need to run your Catkin make for compiling your code from the workspace directory. So you run your Catkin make here. And now if you see here, you will make your package name will be mentioned here. So what and all packages you have, all of those package names will be mentioned in here. So after this, again, you need to source your setup file. Source devel/setup.bash. So every time you create a new package or make a large change in your file, in that case you have to compile again and then run your source. If you don't want to run your source that many number of times, you can add this in your bash rc file. There's something called as a bash rc file. You can add it there, but I think you can just run it for now. It will not be much of a hassle. You have to do this Catkin make and sourcing only when you're making major changes to your file structure, file or folder structure. Otherwise, if you're just making minor changes in one or two files, your script change, you don't have to rerun this compiling and stuff again. I think you can skip all of this other stuff. So till now, we saw what is a workspace. We saw what command to use for compiling your code, and then that you have to source your terminal. Other than that, there is Catkin create package command that you use with your package name and any dependencies. So this will be using, this is a command that you will use for creating your package. And after creating your package, again, you have to compile your code and then source your code again.
What's the difference between source and bash?
Source and
Bash.ba such.
bash.
Yeah.
Bash is a type of file. Source is a command that you will use for your terminal to load this bash file.
Okay.
Okay. After this, this was all about creating a workspace, creating your package and compiling your package and sourcing your terminal. So now moving into ROS concepts, we will see what terminology is there. Yeah, I think we completed this, building a ROS package. Yes, we completed this. You do Catkin make and then you source it. So that's one type. We have completed this. Now we will see what is a ROS node. ROS node is a terminology in ROS that we use. I think you are aware of the term node. So whenever you have a large set of how do I tell this? Node is like a single file or a single executable that you have. Okay, this is like a very quick summary here. I'll just follow this. So we have a concept called as node. What is a node? It is an executable that uses ROS to communicate with other nodes. So I can tell this like you are writing a Python script, you are writing another Python script. These both Python scripts do two different tasks, and if there's any communication that needs to happen between these files, that is done using ROS. So node is an individual executable or a piece of code that does a single task. That is a node. And then message. So we just told that these nodes communicate to each other using the ROS framework. So when you want to communicate something, there is something that you're exchanging, right? That is a message. So suppose there's a node 1 and there's node 2. There is some information being exchanged. That information is a message. So generally, we use something called as subscribing and publishing for communicating the information. So to give you a clear picture of all of this, there is node 1 and then there is node 2. So I want to send a message from node 1 to node 2. So in this case, my node 1 will be a publisher because it is the one sharing information. And my node 2 is receiving the information. So I will call it as a subscriber. Now, to give you a clear picture of what is a publisher and subscriber and how this message is shared, I'll give you an example. There's tank 1, there's tank 2. There is water flowing from tank 1 to tank 2, and water flows through a pipe, right? So my node 1 is a tank, my node 2 is another tank, and the flow in the direction from which it is flowing, if it is flowing from a tank 1 will be the publisher. If it is flowing towards tank 2, my tank 2 is a subscriber. And the pipeline or the channel that is used for sharing information, that is called as a topic. I hope this much is clear. There is node 1, there is node 2. These are executable files or the basic units of your software. So the node that is sharing the information is called as publisher, and the node that is receiving the information is called as a subscriber, and the information that is being shared or the message, it is shared using something called as a topic. It is a channel. You can say this topic as a channel. Now, another example that I can give is like there's a broadcasting net. Okay, take example of a TV. So you have a channel, right? Over this channel, there's some show that is being that is running. There's a show coming on your certain channel. So the one that is sharing this information, that is your broadcasting channel, and the user that is receiving is another subscriber. So there's a publisher, there's a subscriber, there's a channel, and there is some show that is running. So something like that. You can have multiple channels and multiple messages running at the same time in your network. So suppose there is node 1 and node 2, and there is a information that is going from node 1 to node 2. Now I can have another node called as node 3. So it can also be a subscriber to the same node 1, and it can have the same message that is going to node 2 also. So in this case, it will be one single publisher and multiple subscribers. there cannot be multiple publishers again. There can only be multiple subscribers. Or if you take example of a newspaper again, there are different newspapers. That means companies. There's Hindustan Times, there's Times of India. So these are different publishers, and there are multiple subscribers again. 3 people can subscribe to one newsletter, or another 3 people can purchase or subscribe to another newsletter, something like that. There's only one publisher for one topic. For one topic, there's just one publisher, but there can be multiple subscribers. And the information that is shared through the channel is called as message. I hope since this is like a basic concept, I think you guys are clear on this. There is something called as a topic, and over this topic there is some message that is being communicated, and for per topic there can only be one publisher, and multiple subscribers can subscribe to the same topic. Hope this much is clear. Any doubts on any of this? The terms that we are using here is node, publisher, subscriber, topic, and message. So these are the terms that we are using in ROS. ROS, publisher, subscriber, topic, and message. So let us say, speaking in terms of robotics, let us say there is a camera. It has some data, that is the image data. So this image data, I want a certain Python script or an image processing script to read to this image or the image data that the camera is sending. So I have to share this data over my ROS network. So the publisher is a camera node and subscriber is my image processing node. I'll give a topic name over which this message or the image data is being shared. And the nodes involved are my camera node and my image processing node, something like that. Topic is moreover like a names that you're giving for a certain message. There can be multiple messages that are being shared in a framework at the same time. There is maybe, let us say, ours is a mobile robot. There is odometry or the distance information or object detection. So you need to pass on sensor data, right? To see how close is an object, or from any of the sensors. Maybe let us say we are making use of a LiDAR. So we are using that data that is being shared. And this, again, you have a camera. You're sharing image data. You're sharing your image data, and you have some other sensor. So you're sharing. Suppose you have 3 different sensors. You are sharing 3 different data at the same time in your ROS network. So you need a name or an identifier to differentiate the channel,
Data.
which channel has what information. So that is your topic name that you're giving. So which channel has which information. So you're using a topic name as an identifier to identify your channels. Okay, this topic one, I'll name this topic as image data. So I will know that this topic or this channel has image data. It is coming from the camera node. Suppose I give odometry. So I will know that this certain topic has odometry data. So my subscribers can know which topic to subscribe to. If I cannot ask an image processing node to subscribe to odometry, right? I will need image data for that. So this is just your naming your channels. The topic is nothing but your name that you're giving for your different channels. And the messages in each channel will be different again. In odometry, you will have your distance data. In image data, you will have your camera information or your image data. So something like that. So message types will be different in different topics. I hope these concepts are clear, these topics or this terminology that you're using. Do you have any confusion in any of this terminology?
Can one publisher have multiple channels to different subscribers?
No, one publisher can, okay, one channel has one message type, one publisher, and multiple subscribers. So image data is a topic. So node 1 only can publish to it, but multiple nodes can receive it. Again, node 1 can be a publisher to another topic also, and it can have different subscribers to it. It's not like one node can only be publisher only once. That cannot be. But for one topic, it's only one publisher. But one node doesn't mean it can only publish one. It depends. The central point here is the topic. Or one channel has only one publisher and multiple subscribers, and only one message type. You cannot share multiple messages over just one topic. And suppose my node 2 and 3 are subscribing to one topic. It doesn't mean that they cannot publish to another. My node 2 can publish to another topic. And maybe this time my node 1 can read from this. So a publisher can also be a subscriber. A subscriber can also be a publisher. That won't be an issue again. But for one topic, there's only one message type and one publisher, but you can have multiple subscribers, or no subscribers also works. That means my data is being published, but no one is listening to it. That's it. Good example, in class, we have a teacher giving a lecture and none of the students listen to it. They are in class, but they don't listen. So no, zero subscribers. So even that can happen. That is a day-to-day example. Okay, any other doubt on this? Because this is like a basic framework, or this is how your entire ROS works on. This is like the basic pillar that we have here. What is a node? What is a topic? What is a message? Publisher, subscriber. Because whatever code you're writing or whatever the information that you're passing, your whole code, it goes over these minimum topics. So I want to make sure that you guys are clear on these topics, at least conceptually. Then we will see a code. In terms of code, we will see how to write a publisher node, how to write a subscriber node, and then we will see what a topic looks like, what a message looks like. I'll give you a demo on these things, how to create these things. But at least I want you to make sure that you understand the concepts here, what it is.
So here, image data is topic, right? Not message.
Yes, you can. I mean, topic name you can give anything, okay? But
Okay.
the message type is IMG.
Okay, so the type message you say,
This
you just
is
define the type, is it?
Yeah, image type, message type is different from your topic name. Topic name I can give even camera data, doesn't make a difference. Suppose I have two cameras, I can give cam 1 data, cam 2 data, cam 3 data, but for all of that my message type will be image only.
Okay, so when you say message, you mean the type of file that you're feeding it into the thing.
Yes.
All right.
Okay, I think you guys are clear till here. So moving on, yeah, I told you about ROS master also. It helps nodes find each other, or helps run your ROS commands. It will help you find other ROS nodes, or to keep a track of what topics are there, what information is being shared over your network, and all of that. We'll come to that later. But ROS master is what you have to run first to establish your ROS network. And again, you have some you know certain commands again to check what nodes you have. This is a command. If you run ROS node list, you'll get a list of what and all commands or whatever nodes that are active in your ROS network. Right now in my ROS network, there is no nodes active. there's only ROS out that is used to add my ROS master. So whenever I'm running my ROS master, this automatically comes. Other than that, if I run any other code now, new nodes will be added because those nodes are active. So ROS node list shows me a list of active nodes. And then there's another command called as ROS run. ROS run is used to run your files. Simple. It is used to run any executable that you have. And the basic syntax is you have ROS run and then you mention your package name where your executable or your executable is nothing but your Python file or a C++ file, your script basically. After you compile, it becomes a executable. So you will give your package name where that executable is stored and then the node name or the executable name. So TurtleSim is a default package that is already in my system, and TurtleSim node is my script file or the Python file name or the C++ file name that you want to call it, whatever you want to call it. It is basically an executable name. So if I run this, this certain file, it will launch this GUI where I have a single turtle with a 2D map. So now in a new tab, if I check for ROS node list, you will see that there is a TurtleSim node running here. Before there is only ROS out, but now in my active nodes list, I had TurtleSim also running. So
How to control that turtle?
for that, yeah, I'll come to that also. Okay, we can cover that first then. Okay, first we have launched the TurtleSim node. After that, okay, I'll show this thing first then. Like just like how we check the ROS node list, there's something called as ROS topic list. So if you run this for my TurtleSim node, there are 3 different topics or 3 different channels of information that are being run from my TurtleSim node, single node, and there are 3 different topics over it. Okay. First topic I have is turtle1 command velocity. This is my topic name. So if I want more information on this topic, what I can do is I can type ROS topic info and my okay. Oh, sorry. Okay. ROS topic info and my topic name. If I give this, I am getting the type of message that is being used. Geometry messages twist. So this is a message type, just like how we have integer, float, and string, character. These are like basic message types, right? That we use in normal programming. But when it comes to our ROS, we have a little bit more complex message types because whatever information we are passing is a little bit more complex. Just for example, if you take image data as example, image is nothing but a pixel or it's a pixel, right? It's a matrix of pixels. So it is more complex. Similarly, suppose if you want to share a point that you want to go to or space, you will have to share XYZ coordinate, or again to share your information of the angles, you might have to share your RPY. I think you know what is XYZ and RPY. That is like the basic ones. It's a geometry thing. It's just your translation and rotation data. So similarly, the twist message here is nothing but your it has your XYZ and RPY. XYZ is how much it should move or with what velocity it should move in terms of X direction, Y direction, and Z direction. And RPY is nothing but how much it should rotate about x-axis, y-axis, and z-axis. Suppose you have a, let us say, a car or an RC car or whatever. It can move in x direction, but it can't move in y direction. But if you can rotate your wheels, yeah, it can move in y direction also. It depends on what kind of a robot or what kind of, the differential drive it has, or else how much it should rotate. Again, your car can only move about x direction. It can't move about y direction. It cannot move laterally. Like suppose I want my turtle to move. I can only ask it to move in this direction. I cannot ask it to move this way. Even when you're walking, you walk straight. You can't walk. I mean, you can walk sideways, but your car or whatever, because it is placed on wheels, it cannot move sideways, right? If you want to take a left turn or right turn, that will be how much you're rotating about x-axis while you're moving forward. So suppose you have to make a turn like this. You're still moving straight, but you're making a rotation about your x-axis here. That means you're turning this way. So that is your rotation about z-axis. Sorry, z-axis it is. You're still moving in your x direction, but you're turning around in terms of z. So that is how you make a U-turn or a turn around, basically. So here you are giving information about x, y, z and RPY. That is how much you are going forward, or I mean, see, even if you give a y value and z value, it doesn't make sense. It cannot move in that way. So basically, this geometry message twist, it has, XYZ and RPY, something like that. Publishers, as of now, there's no publisher. That is the reason my turtle sim is standstill. So my turtle is standstill because there's no publisher. And my turtle sim node here is subscribing to this. I mean, there's no publisher as of now, but there's a subscriber, so the topic still exists. If there's a publisher to this topic, then my turtle sim, because it is listening to the channel and there's information available, it will start moving. I hope this concept is clear. I have a subscriber, I have a channel, but I'm waiting for my publisher to come active.
So where exactly will we use this turtle simulator?
Sorry, where exactly?
What exactly are we using this turtle simulator for?
This is just to replicate a robot, like a 2D drive. See, you in your okay, you have a robot. It's actual robot. It is more complex, but this is like a very simple robot to understand your ROS topics. And it's like you have a 2D map. You have a robot, or like this replicates like an RC car, where it can go forward or it can turn about the z-axis. It's like simple replica of a simple RC car or something like that. It's just to understand how to drive this or how to pass information and stuff like that. Basically, this turtle sim was made for that purpose only, for learning ROS and trying out different things, how to publish to it, how to to get an idea of how things work. What is a topic, what is a publisher, what is a subscriber, just to understand this, how topics work and all that. This 2D graph called as turtle sim was made. But this is like a replica of a robot here that you have.
So more like to debug your code before you actually feed it in types.
Something like that. But more like it's for an educational purpose or for a learning purpose. This is just a replica of a RC car kind of a thing.
Okay.
This was made for learning itself. Nothing greater than that. This turtle here is replicating a robot here, and this is a 2D graph where it can move about. And then we can ignore the color sensor. Color sensor is nothing much here. It's just about the background here. We can ignore that. That's just like an added feature, I would say. And then we have something called as turtle one pose. If you check this out, wait, I think I didn't copy it. Okay, now if you check this topic here, there's a publisher, turtle sim. That means this node here, but there are no subscribers here. So this turtle sim pose is nothing but it is giving out its current location where I am. Suppose this is XYZ as 0 here. It is telling I'm in XYZ 0 here. If it moves here, it will tell I'm in 1000. If it is here, it will tell I am at 110 position. Something like that. You understand how a graph is, right? Graph coordinates. So suppose let us say this is the start of x-axis and y-axis, and this is the origin. So this will be 0 0 0. It comes here, it will be 1 0 0 0. If it goes here, it will be 1 1 0 0, something like that. It is giving its post information, but there are no subscribers here as of now. So suppose I want to run a code that says when my turtle comes to this position, I want to do some certain action. In that case, I will subscribe to this turtle one post and wait for the post information that this turtle is publishing. So I will know when it is gonna come here, and after it comes here, I can take a certain action. Maybe I want my turtle to move in this direction, and when it comes here, I want to stop it. How will I know it came to this position? When I subscribe to its turtle post. So suppose turtle sim is an node here, right? And I am telling I will be sending messages to turtle one command velocity topic. So my turtle sim is subscribing to it. So according, if I give x is equal to 1, so it will move in terms of x direction with a velocity 1. And I will also subscribe to its post. And when it comes to this location or this certain post, when I receive this information that yes, it came to this post, I will change my velocity message to x is equal to 0. Then after coming here, it will stop, because whatever I gave x is equal to 1, that is the speed or the velocity with which my turtle should move in x direction. So now I'll change it to 0 because it came to the target location I wanted it to come. So that is how you can make use of these topics. I mean, you're publishing to turtle sim to move in one, and after you're subscribing to post to know when it came here, and after you'll again more like a feedback system. You're telling go with a speed of 1, and you're kind of taking feedback. If it is in this point, it is in this point, it is in this point. Afterwards, it came to your target position. So now you're updating your command. Now you're updating your velocity to 0. So your turtle will stop. Something like that. You're giving and taking information. And all this data that you're sharing or receiving, that is happening over different topics or different channels. Suppose I have two turtles, one in this location and one in this location, and I want to give the same data. I want both my turtles to move in the same direction, in the same speed. And when my turtle comes here, I want this to stop. When my the other turtle comes to this position, I want it to stop. So that time I can again code it. Turtle 1/post, turtle 2/post. I have two different topics now. Okay, now I have turtle 1 command velocity, turtle 1 post, right? Similarly, if I bring in another turtle here, I'll have 3 more other topics with the name turtle 2. So something like that. At least I hope you got an idea.
So if there's a script file like in which I have the commands to what coordinates it should go at, does that make that script file the publisher?
Sorry? Yeah,
So
like
if
the
I have,
information.
yeah, if I have like a script file in where I put the code for where the turtle should move, does that make the script file like a publisher node and the turtle sim like a subscriber node?
Yes.
Okay.
If you're giving information where to go, that means you're giving information. So you're publisher. And this turtle is receiving the information. So this is the subscriber. And you are receiving the post. So this is the one that is sending the post or data. So this is the publisher, and you are the one receiving it. So you're the subscriber. Vice versa. And now there is something called as a turtle teleop key. Again, this is also a default function or a default topic. So when again, this is also in the same package, turtle sim, and this is another node called as turtle teleop key. This is the node name. So when I run this, you will be able to move your turtle using your arrows. So suppose I click the arrow, like the above arrow, it will move front. If I use my right arrow, it will turn right. If I use again straight arrow, it will move front. Again, I want my turtle to rotate right. I'm giving right arrow. So you can control your turtle using your arrow. Now if you take a look at how your ROS node, okay, um there's one more command that is very helpful called RQT graph. Okay, now if you look at the RQT graph, this is just to get an overview of what all nodes are running and how the data is being shared. Suppose you have a lot of nodes and a lot of topics and a lot of information being shared. So you will need a visual representation to understand, right? It's not like everything you can just grasp by looking at the commands or a list of nodes and a list of topics. You cannot run every single topic to see who is a publisher, who is a subscriber. So now if you see this RQT graph, this is nothing but a visual representation. Turtle sim is a node, teleop turtle is a node, and then there is an information being shared from teleop turtle to turtle sim, and the topic name is turtle1 command velocity. This is a topic name. So this because it is this teleop turtle is a node that is taking information from the arrow movement and telling which direction it should move for my turtle sim. So this is a publisher, this is the subscriber now. So this is the arrow mark from publisher to subscriber. So it is directed from publisher to subscriber, and the topic name is given here. So suppose I have one more node that is receiving post information, then this will be the publisher. My other node will be here, and there'll be a directed arrow from here to here, and the topic name will be turtle1 post. Something like that. It's a visual representation of nodes and topics and the direction in which the data is flowing. So that was about RQT graph.
Can I control that turtle with the help of VS Code?
Yeah, you can write a publisher node. Okay. Okay, right now what this is doing is, this is taking the information from my arrows and then it is publishing that data to the topic command velocity. Instead, you can write a publisher node or your own script where you are publishing this data to the same topic, and you can control it via your script. I will show you how to write a publisher node and a subscriber node now.
But I'd have to only control it. Is there no way the turtle can move on its own, like specifying the coordinates in the Python script and running that Python script in the terminal?
Yeah, you can. You have to write an algorithm to how it is, not exactly an algorithm, but you are again receiving this post information and the twist message. You have to coordinate between these two. Like I said, this was my starting position. I want my turtle to come here. So I'll be publishing my x direction information, like go with the velocity 0.5, 1 or 2. How fast you want your turtle to move. So that information you will be publishing to this topic, and that information is being subscribed by your turtle. So it will move, it will take that command, and you will be subscribing to your post to know when it has reached, and then you'll update your velocity to 0. Like you give your velocity to 1 until this reaches the position you want, and because you're listening to your post, when you know that it has reached this point, you will update your velocity to 0, so it will stop there. Same like how you're driving a car, you will give accelerator till the point you want to go, and after you reach the point you wanted to reach, you will hit your brakes, right? Something like that. Same as that. Now suppose I'm driving a car, I am giving accelerator, I want to reach 1 kilometer ahead. I'll give accelerator till I reach that point, and I'll have this visual feedback. Okay, I reached 750 meter more, 500 meter more, 250 meter more, 0 meter more. That means I have reached. I have this visual feedback coming. And once I know I have reached that position, I'm hitting my brake. something like that. I'm updating nothing but I'm updating my acceleration from 1 to 0. Before I was giving accelerator, now I'm giving brake because I know I have reached a point. How do I know I have reached a point? Because I'm seeing it. In this case, you're seeing it from you're knowing it from the information that you're subscribing to here from this topic.
Okay, but can I make the turtle go in the form of circles? How do I do that?
Yeah, if you can make this turtle move in the shape of a square. You can make it circle like this, or yeah, you can increase the direction or the radius. All of that you can give depending on how much you're rotating. Like if I am using a car, if I turn my steering to like full right, my car will rotate with a smaller radius. If I don't give much steering, I just give little steering towards right, it will take a large radius. Similar to that, you can control your steering depending on your rotation along z axis. That again you can give in this twist message itself, how much it has to rotate in terms of z axis. RPY.
Can we like tell it to stop? I mean, go till one and then stop over there instead of going back and updating the coordinates?
You cannot. I mean, how will you know if you don't keep getting your feedback? You have
I
to
mean,
keep
like,
listening, and you have to know when it has reached. Right? You're listening to you keep listening to the data, and when it has reached, you stop. That's how it is. You have to keep listening to only know when it has reached. You will not suddenly know how it when it reached. Okay, now we'll quickly look at how to write this. I think you're running out of time. Okay, I covered ROS topics, services and parameters. I don't think you'll be needing for this. RQT we covered. There's something called as ROS launch. This I will tell you in some time. But we will move on to this. Okay, we have covered this also, ROS nodes. Okay, we will move on to the creating this subscriber and publisher nodes. How do you use it in terms of scripting? Now we have seen a visual way by running the existing packages, but how do you write your own publisher and subscriber? This is like a basic hello world example in ROS. Okay. Where do I create my file again? In your workspace, you move to source and then your package, and inside your source folder or just inside your package, you can create a file. You can name your file with anything. I'll be using you can use any editor also. You just have to create your file there and copy paste the code or write your own code. I have named my file as talker.py, and here I'm pasting my code. In my case, this is a Python file. You can even write a C++ file depending on your which language you're familiar with. This first line here, you are telling the path to your Python environment. In all of your ROS files that you're writing, you have to do this. If you want to use Python 3, you can just mention Python 3 here. The location will be same. It will be in your user bin environment file. This is like a common thing. If you don't write this, you will get an error because it won't be able to identify Python language. You can ignore the comment. Okay. First, I am sure you all know Python. First, you're importing your library files. My library file here is ROS.py. Again, if you remember, when I was creating the package, I gave a dependency called as ROS.py. So now I can use that library here. ROS.py I'm using to use some functionality inside it. Like when we are importing math file, we can use square root function, we can use power function, something like that, right? Or sine, cos, whatever you want to use, all the math functions that you want to use, you will use. Similarly, in ROSPy, I have publisher function. I have something called as rate and something like that. To know if my ROS network is up or it has shut down, that is, if my ROS master is running or not. And then rospy.log info is similar to your print statement. You can even give print, it does the same thing. It will just mention your information to your console. Okay, so I'll walk through the code. First thing, you are importing your rospy library, and standard messages again is your you're just you're importing your message type. In normal messages, if you in a normal Python code or something, you can just directly use it, but here you have to import them, even your message types. So in standard messages, there is a directory called as message. So you're accessing that using the dot operator. Standard messages dot message. You're importing string. String again is a data type. Or in this example, we saw geometry messages twist, right? So in this case, what you'll be writing is from geometry messages dot message import twist. Or in this case, post. Sorry, what was this type? Turtle sim post, right? In this case, you will be writing from turtle sim dot message import post. That is how you will be writing. That is how you import the data types. And then two parts of your coding. One is your main, and then any function that you want to define. So I'll come from main because that is how you run your normal. That's how your program runs. After the import statement, it will directly start from main. So you're writing a try and except block. In try block, you are calling a function called talker, and in your talker function, what you are doing is you are creating a object called pub, or in short for publisher. So you're calling the function rospy.publisher, and you're passing some parameters. This first parameter is your topic name, and then the message type, and queue size or buffer size. That means how many messages you want to hold in your topic. That means something you understand what is a buffer, right? Like you can hold up to 10 messages. Every time a new message is being updated, the old one is getting lost, something like that. You're defining the quantity of your channel, how much it can hold. So you're creating a publisher object here, and then you're initializing the node. This is the node name, like how we have turtle sim as a node here and turtle teleop key as a node here, something like that. I am naming this node as talker. Generally, whatever file name we give, we use the same node name also, to avoid confusion. There's no big logic here, just to avoid confusion. One node per file is what we generally do. And then anonymous is equal to true. You can ignore this part. This is because every node has a node id kind of a thing, but if you are using same nodes, every same node names, this anonymous is equal to true will help you that time to not get confused. But you generally won't do that if you still want to remain same. If you want to go insane, you can give the same node names and get confused for your life, but generally we don't do that, so you can still ignore this part. And then something called as rate. This rate is how many messages we want to publish. So this again, it is in terms of hertz. Hertz is nothing but 1 by time. That means 10 messages per second. This is per second. So you are defining your rate. That means you're gonna send 10 messages per second, and your queue size is also 10 here. And you are writing this while rospy is shut down. That means your ROS master is still up. Your ROS network is on, is not off. Only then you will run this code, or else you'll get an error because it's not active. You are defining a message, a string message. This is a variable hello string, and then you are storing information hello world. And rospy.getTime is something like an added feature that added string. You are just customizing it with your time now. Like right now it is 8:35, right? It will give with seconds also. I mean, I just to make sure what time this message has been made or what time this message is generated. And then rospy.log info is similar to your print function. You're just printing this hello string to your console. And then publish.publish is you're publishing this message onto your topic charter. You can ask why are we doing this. This is for us to know, but even without printing it, it will still keep publishing the information on charter also. I mean, even if you run this without this log info statement, this data is still being published to your charter, and when you write a subscriber, it can still listen to it. And then rate.sleep. Rate.sleep is, suppose you want to, okay, you set your time to 10 hertz, right? So if you don't want to do it, that means you want you want to send only one message per second, then you give rate.sleep. That will just waste the buffer time. That you will be adjusting the time with how much the frequency with which you want to publish. This is just to adjust your time or keep track of your time. You can ignore all these extra features. You don't need to keep track of them. All you have to note here is how to define a publisher. It has rospy.publisher. The parameters are your topic name, the message type, and queue size. And you are initializing a node here. In initializing node, you just give your node name. Node name will be similar to your file name in general. And then you will use this construct when your rospy is not shut down. And then whatever you want to publish, you will be publishing that. You'll be generating your message, or you'll be defining your message, and then you'll be publishing that. This is the main points you have to remember. What you do, you initialize your node, you define your publisher, you generate your message or define your message, and then you publish your message. This is what you will do. This is your publisher node or any node in general. So this is the main things, that observation points that you have to make here. Any doubts here with this talker.py? This is how you make a publisher. Any doubt here? Anything? If not, I will run this file and show you what happens. I have saved the file. Now my ROS master is still running. So I can use ROS run. I think I have to compile my file because it's a new file that I have added. In Catkin workspace, Catkin make, and then I have to source it. Now I am running my ROS master using the command ROS core. And now I will run my file, ROS run. The package name is ROS pack. And the thing, you have to source every file, every terminal that you use, you have to source it. That's a backdrop here. I don't like it. Source table /setup.bash. So now okay, there's a lot of that ROS package and docker.py. Okay, one more thing, you have to make your file an executable. Inside, okay, this is your docker.py, right? You can go to properties, and then in permissions, you can give this allow executing file as per program. You can just check this execute permissions. If you want to do it through your script again, you can just open a terminal here. In this location, you can open a terminal, and then you can use the command change mode /x docker.py. This is how you do it through code. But if you don't want to do it, I feel it's a hassle. It's better to use a GUI. Just go to your properties, in permissions, check the execute box here. So now you can run the code. Now you can see that it is being published. My information is being published. So this is the time that is getting appended. This is in terms of ROS time, not my usual this time. So ROS time is since you started your ROS master, how long has it been? That is in terms of my ROS time. And this here is my, again, ROS time itself. Same thing. So now if I check for ROS node list, you will see that there is ROS out and there is a token node. Since I gave anonymous is equal to true, I have this extra information being appended. So my node name stays unique. So now even if I run multiple nodes with the same name, the anonymous part is gonna be different every single time. But suggested not to do that. Keep your node names unique. And then ROS topic list, there is charter. So this is the topic name that we gave when we were defining our publisher. I close the file. Okay, I can open it here. Okay, charter is the topic name that we gave. And if I go for ROS topic info and my topic name, I will see that type is standard message is string. String is the message type that we gave here. And publishers are my token node. That is nothing but this node that is publishing to it. And one more thing you can do is ROS topic echo, and then if you give the same this, you can listen to your data. Whatever data is being published, you can make that almost like you're listening to what is happening inside your. You can print your data here. ROS topic echo is the command there. So now we saw how to do a token node. Do you have any questions with the publisher node? If not, we can move on to subscriber. We are short on time. But if you have any doubts, it's important that you understand.
Is Chatter the name of the publisher?
The name of the publisher node is Docker. Charter is the topic name. String is the message type.
Okay.
Any other?
But the topic name is standard underscore messages, right?
No, this is your node name that you're giving. Node name is nothing but your file name, or whatever you want to name it. Instead of Docker, I can give my name also. It works. You can give your own name, or whatever you want. Suppose suppose I gave you an example, right? Suppose you have multiple cameras and you're getting the data. So I can give this as I can name this node as camera 1, and my channel name or topic name as camera 1 image, and my type will be image, something like that. So suppose if you're taking camera 2 data, I can name my node as camera 2 and I can name my topic as camera 2 data, and but the message type will remain string, again image there, something like that. You can name your node anything, that is fine.
Okay, so talker is the name of the file, and chatter would be the name of the
Topic.
the topic. Okay.
Yeah.
And standard underscore messages is the name of the package.
Standard underscore messages is a package name or more like a library file for you. From this library file, you are importing the string data type.
Okay, cool.
Okay, anything else? Okay. For now, I'll stop this node and I'll show you how to create a subscriber also. So now we saw the publisher node. Now for subscriber node. Okay. I will name this as listener.py. That was talker.py and now this is listener.py. Okay, this is the code. I will give you a breakdown of what is happening here. Again, you are giving the path to your Python environment. And then you are importing ROS.py library. And again, from standard messages, you are importing string data type. And from your main function, you are just calling the node, function listener here. And in your listener, you can ignore all these comments. You are initializing your node. This is a must. For every node, you must initialize a node name. Again, your node name is same as your file name here. And you can ignore this part. Anonymous is equal to true or false. It doesn't make any difference. And then you are defining your subscriber. For publisher, you had to make an object. But for subscriber, there's no need to call an object. I mean, you gave something like this. This pub was an object here. And using this, we used to publish it. But for subscriber, you don't have to create an object. You can just directly call a subscriber. For this, the parameters you're passing is the topic name that you want to listen to, what data type you're expecting, and where you should send this data to. So this callback is a function again. And rospy.spin, you're writing this so your code doesn't exit. So now if you have just you got a data and then it will send this data to your callback function where you will use the data and do some operation. And after that, you don't want your code to exit just after listening to one data, right? So you just still want to keep listening to your data. You don't want your code to exit. It's more like a feedback where you continuously keep listening and wait for something to happen. So you see, because you don't want your Python code to exit, you will use this rospy.spin. Spin will keep your Python code running. That is what it will do. And whatever data you're receiving from this, it will be sent to your callback function. Instead of callback, if I give some other function name here, it will go to that function. So this function, whatever is there, that I will be defining again. So callback, I am receiving certain data. And what I'm doing is I'm simply printing it on my terminal. I am getting the caller ID. You can ignore all this part. You don't have to know what it is also. You can simply tell I heard this data.data. So data is this variable and this will have some other extra information appended to it. But the actual message is in .data inside it. Something like sending node or something, some extra information it has appended with it. But the main data will be stored in this data.data. Suppose if you're naming this something else, suppose I am calling this parameter as image, then you will have to write here image.data. Dot data is the actual part, but whatever name you're giving here you can, whatever name you're giving here, that will be remain the same. This is just the argument name, but dot data is where your actual data is. So suppose I'm listening to my post data. I will write turtle sim slash post, and I'm expecting a post message type, and then I will send it to this callback function again. Instead of callback, I can name it to something else. I can name it anything, and I can name my message as just post, and I'll be like post.data. And if post.data dot inside that, I am looking for in my xyz coordinate. Suppose I'm checking for my x coordinate, I will say post.data.x. That is how you differentiate your data. Okay, I can show you a message type, for example. There is something called as ROS. Is my ROS code running? Yes. ROS message show geometry messages slash fist. This ROS message show and your message name. It will show you the how your message type or how it is defined. In my case, it is linear x. So suppose I want to access this variable, this particular variable. How I'll be doing that? I'll be calling, suppose my variable name is data and it is of type geometry messages twist. So when I have to access this particular variable, I will call it as data dot linear dot x. If I want to access this particular variable, I will call it as data dot angular, data, okay, wait, I'm giving here, right? So data dot data, which is my actual data, dot angular dot x, something like that. To keep it clear, suppose my variable name is, let us say my variable name is var, a variable. So this is my argument name. To access particular variable from that, I'll be using the dot operator to traverse. So variable dot data, which has my actual data, dot linear dot x, that refers to this particular information, or angular dot z, something like that. So this will be your message type. So you have 6 different float variables here defined in terms of vector 3. Vector 3 is nothing but xyz coordinates. So these are message types again. Geometry message is vector 3. It has 3 different variables xyz of type float 64. Don't get confused with all of this. Kind of little complicated for the first time if you want to take in, but yeah, this is how you traverse your data. Your argument name dot data dot linear dot x, linear dot y, linear dot z, angular dot x, angular dot y, angular dot z, something like that. But I don't think you have to go into that much of complexity for now. Okay, I hope this is clear here. In this, what you're doing again, for your subscriber, you are initializing your node. After that, you are calling you're defining your subscriber, and inside that you are mentioning what is your callback function. So you're calling your callback function, you're mentioning which is your callback function in your subscriber itself, and then you are defining a callback function where you will receive your data. I hope this much is clear. This is how it runs. You are initializing your node, you are defining your subscriber, and you are sending the data from this subscriber to your callback function. And in your callback function, you will perform whatever operation you want to perform with your data. Hope this much is clear. Any doubts here? I think I made it a little complex, but yeah. If not, I will run this code and show you. But take time to process it while you're seeing the demo itself. Again, I will have to okay, I saved this in the wrong place. Now again you have to make this also file this file also as an executable. After that, this already says. I am running my talker.py. So now my publisher is active, and then here I will run ROS package listener.py. So now you can see here it is printing I heard hello world with the time whatever it is hearing. And you can see that there's some additional information also being printed, like where at what ROS time what node is it is hearing. This is my ROS node, the node name that is coming. Now if I take a look at my ROS node list, you will see that I have a talker node, I have a listener node, and my ROS topics, I have only one topic, charter, because both subscriber and charter, sorry, but my both publisher and subscriber are using the same ROS topic charter. So if I go for ROS topic info charter, you will see the message type, and publisher is my talker node and subscriber is my listener node. I hope this much was clear, how to create a publisher and how to create a subscriber. Have any doubts, please ask.
What's the command to run the subscriber file again?
Same, ROS run your package name, ROS run your package name, and then your node name. Any file you want to run, this is how you do it. ROS run your package name and then your node name or file name.
Okay, and before this we compile it.
Compile you do only when you are adding a new package or major change in your file structure, or else not required. I mean, now I didn't compile my code before calling this listener.py. I just created the file, I saved it, and I gave it an executable permission, and I just ran it. I didn't have to compile it.
But if you were doing it in a new terminal, you'll have to source it again, right?
Yes, you have to source every terminal that you are using.
Okay.
And when sourcing, you should make sure that you are in Catkin workspace.
Okay.
Okay, I hope you're clear. Okay, this much is done, and I'm not sure if we have enough time to do this. I was supposed to cover in the URDF and okay, I'll just give you a plain gist. Okay, there is something called as URDF. It's called Universal. Sorry, I forgot the full extension, but it's a file type. Okay, so what this URDF file is, it will describe your robot. So when you have an actual robot and you are dumping your code onto your robot or you're writing your software, how can you be sure that you have written the right code? You have accounted for every use case scenario. You can't write. I mean, suppose you are writing a code for your robot to move in a straight line or something like that, but something goes wrong and it goes and hits a wall or crashes into something. Your robot is gone. That's a costly thing. Robots are costly. That is like a common thing. So just to be sure, we expect for us, we expect to run a simulation beforehand before testing or dumping your code onto your actual robot. It is always best to run a simulation beforehand. There is a software called as Gazebo. I again, this will come if you with your ROS installation only. Just type Gazebo in your terminal and it will open your Gazebo. So this is a simulator. Gazebo is a simulator. So you will bring in your robot here. This is called your Gazebo world, or this is same as your room or anything else you want to create. Suppose you want to add a wall here, you can add it. You want to add a table here, you can add it. So for example, I have few stuff like okay, I'll see if I can add it. Okay, like this is something that I had this model file here that so I could add it here. So something like this, you want to define something, you want to make a room here, you can do that, you can build it. So there's something called as a model editor where you can construct things and all that. So you can add whatever you want to add here and then you can call them. This is, I'm just showing you an example, but okay. So now this is your Gazebo, which is a simulator, and this is called as a scene. There's a left terminal here. So in you this first is world tab. Here it will show you what and all is there in your world. Suppose for example, here I have something called as a ground plane. That is nothing but this ground plane here. And for lights, I have something called as sun. It is actually there here in this scene, but you cannot see it. Or maybe I can show you. Like if I zoom out. Okay. I'm not able to zoom out. I don't have a mouse here. It's best to use a mouse if you're using Gazebo. Okay. Okay. So this is where my sun is located actually. Okay, there's something like that. So suppose if I add another, like, okay, there's a Coke can that I'm adding. Now if I see in my world tab, I can see that there's a Coke can here. Something like that. Okay. This is called as a model and you can insert your models here using your insert tab. But before that, you have to add your model path and all that here. But you can ignore all this for now. You don't get into complexity. So now what we are looking into here is you can add your robot model which you have designed using any software like your CAD software basically. Maybe Fusion 360, SolidWorks or whatever CAD software where you will design your robot. That model you can you can make a description file of your robot and then bring in that robot here in your Gazebo here, and you can run your code. This ROS and Gazebo you can use hand in hand. That means you have a robot running here is what I'm telling you, right? So when you're publishing something or anything, suppose I'm telling my robot to go front, you will actually see your robot moving front here. So something like that, like how we saw in Turtle Sim. We had to publish to command velocity. In a similar way, whatever robot you're bringing here, you will set up some topics for that. And if you're publishing to that topic and asking your robot to move front or something, you can visualize your robot moving front here, something like that. Instead of directly executing it on your robot, you can do it in a simulation. Okay, clear till here? Gazebo is a software simulator. You can bring in your robot model here in your simulator. You can execute your ROS nodes or whatever scripts, and you can look. You can see your robot actually moving or doing some task, or if it is crashing, or if something is not working, you can visualize it here. Basically, you're simulating your robot here. Okay. Yes or no? Okay, I will.
Will there be any coding required in Gazebo?
If you are in Gazebo, Gazebo is nothing but a simulator. It is just your replica of your actual world where you'll be placing your robot. But actually, to control your robot and all that, you still need coding, right? The way how are you passing your information and all that. So for that, you will still be using your code.
Yeah, the
Gazebo
publisher
again is
and
a standalone simulator. It doesn't have to exactly be run with ROS, but for ROS to simulate things, we use Gazebo.
okay. So we don't really code within the Gazebo environment to.
No, Gazebo is just to visualize what is happening. You don't code anything here. Right now, I just showed you how to write a publisher node, subscriber node, right? Similarly, for your robot, you create a topic and you'll be publishing, you'll write a publisher to send data into that topic, and your robot actually moves. That is how it is. Whatever your coding is being done, that is in your ROS. In the same way, publisher, subscriber, topics. This is how it. That is where you will code over publisher's subscriber and topic. Using these concepts, you code your robot. But to visualize how it is moving, right now we visualize the turtle sim moving, something like that. If it is a complex robot, you will visualize it here. You will visualize your robot here.
Okay, so how do we integrate the Gazebo and the ROS one? To see
I
it move?
will. Yeah. First, we will see how to bring in your robot here. So there is a file called as URDF. It is an XML file. XML is nothing but it's a little bit similar to your HTML. It is done using tags. You have to define how you're providing a description of your robot. Like you will define your robot name, and however your robot is, you are describing that in terms of links and joins. So your robot is not whole one piece, right? It is made of different parts, and then you are bringing in together those parts. So your link is nothing but a single part of your robot. Suppose you are taking I will show you first. Okay, so here we are constructing a basic one. So here they are naming the robot as my first, and they're giving a link called as base link. You'll be naming your links, and visually you're defining the geometry of it. Your geometry is nothing but a cylinder of length and radius. You can do this, and then you're closing all the tags. So something like you're defining a cylinder here. Okay, but if you can also use mesh files, if you're using CAD software to define your to design your model, you can convert it directly from there using a plugin. You can directly make your URDF file. You can generate a URDF file. But to understand how it is, your it is in terms of this tags, your robot name, your link, and then you will also have something called as joint. Okay, so suppose there is a base link and there is a right leg. Okay, and then you want to create a join between them. So suppose yours is you don't want to move your legs or something, you just want to move your hands, so you'll give the type as fixed. Again, if you are aware of like basic robotics terminology, links and joints, there are different types of joint. One is linear, and there is rotation type, and other is fixed. Linear in the linear or prismatic, meaning it will move in x, y, or z direction, any one of these. Rotation in the sense it will rotate about x, y, or z, something like that. Now suppose this is fixed. Okay, little bit more complex if I have to go. Okay, suppose this is my final version of a robot. So now I want this robot to move. I am not operating any of the other links. This is my base link, this is my left leg, this is my right leg, and this is my manipulator. I don't want my robot to move. I just want my manipulator to move. So I will tell base link and left leg. I'll be creating a joint in between them, and I'll tell this is type fixed. And my right leg and base link, again it is fixed. But my manipulator will move. It will open and close. This is linear. Or if I want my manipulator to rotate, I'll tell it will rotate in terms of x-axis, something like that. You can watch some YouTube videos on this, that will be helpful, but because we are running out of time, but I'll just explain how it is done. Okay, this is a huge file, but keeping it simple, you will have your XML version. You can ignore this part, it will work even without this. You have to give your robot name, and materials again you can ignore for now. You will be defining your link, your other link, and the joint type in between that. So suppose your link is base link and your second link is right leg, and you're defining a joint between them. You're giving your parent link as base link and a child link as your right leg, and then you're giving the type as fixed, something like that. And then you're telling the XYZ position. That means where it is connected. Suppose here in this picture, if you see, so this is my XYZ0 of this. So it is connected somewhere here. So I need to tell how much difference it is. Where is the origin here? How much distance is there from this part origin to this part origin? Something like that. You're giving your origin values, how where it is exactly placed. Okay. You can look at some. Actually, you can read through this URDF tutorial page. It is easy only, nothing complicated. You will understand it. As I told, if you're doing it from a CAD software, you will download something called as mesh file. So in that case, you don't have to even give your geometry and all that, like here how you are defining a cylinder and all that. Instead of doing that, you can directly mention your mesh file in geometric place, something like this. You're giving you are saving your mesh file within your ROS package. Suppose this is my package name. Inside that, I'll make a folder called as meshes, and inside that I will store my mesh file. Mesh file is nothing but your design file that you are downloading for your the design file which you are designing in your CAD. So you're downloading that mesh file, and then you're storing it, those downloaded files, in a folder called as meshes, and then you're just giving the link to that package name, your file name. So you can, it is easy only. You're just giving a link name and your origins, and then that is nothing but your coordinates, where it is, and then your file name. Just read through this URDF tutorial page, you will understand. If not, you also have video demonstrations and all that. And how to load this into your gazebo, there is I think all of that is also mentioned here only. Using URDF in gazebo. So now how to bring this model that you have defined in your URDF into your gazebo. So for this, it is simple. There is something called as a launch file. Now a launch file, it is same, an XML file. You can use this launch files to run multiple files. Like suppose you saw now, just now we had to run talker and then listener. So for that I use multiple terminals, right? So suppose I have to run around 5 nodes, 10 nodes. I'll have to open that many tabs. Instead of that, what I can do is I can just list all these nodes in a launch file, and I can just simply run the launch file. It will run all the listed nodes in there. So in your launch file only, you can call in your file inside your URDF also. Okay. Okay. There is something called as a plugin on all this. You can look at this later. I'll just skip to the launch file part. There is. Okay. This is how your launch file will look. You have open and close launch tags, and inside that you are calling your node. There's a node called as spawn. It is in package gazebo, and type is spawn model. And then you are just mentioning, you're passing your URDF file as an argument here. Just read through all this. I'll be sharing all the links. Just read through all these documentation pages and you will understand. You are saving your URDF file which contains the description of your model, and then you're just writing a launch file to you're mentioning the node name, and then your package where the whatever node is defined, where it is stored, and then you are passing your URDF as an argument to this. It's easy only. Your URDF name here, suppose in this example it is table description, so they are passing it here, and where it is defined is table model and all that. Just read through all of these pages and you will understand how to launch this. So all of these links will be shared to you guys. If you have any doubts, please ask now.
If it is not too much, is it possible that you can like put like send a screenshot of your command history in your terminal?
This one.
Yeah. Or where majority of the commands you have put, like in the beginning.
Okay, I can just make a list like this and send it to you if that's okay with you.
Yeah. Thank
I'll
you.
make a file out of it and I can send it to you.
Yep. Thank you.
Okay. Okay, I'll do that then. I'll make a list of all the commands that we executed today with all the resource links in a file, and then I'll send that file over to you guys. But any of the concepts that you have a doubt with, please ask. Gazebo is a simulator. URDF is a file type that has your robot description, and then if you're using a CAD software, you can download your mesh files and use them in your URDF. And then there is something called as a launch file, which is used to execute or run multiple nodes at a time. There is something called as a spawn node. in gazebo package that is used for calling your URDF module